Okay, welcome everybody. Thank you for coming to this session. We're going to talk about new ways to automate compliance using provable security methods. So I'm Chad Woolf, Vice President of Security over compliance, data protection, and privacy. And I'm here with my colleagues. I don't know if your mics are on. Byron, do you want to introduce yourself?
I suspect my mic is on, yeah.
Okay, there you go. Byron, introduce yourself.
I'm Byron Cook. I'm Director of Automated Reasoning Group.
And I'm Tom McAndrew. I'm the CEO of Coalfire.
Great. So thanks everyone for coming. Today we're going to talk a little bit about some of the challenges of traditional audit in the world we're in today. Talk about provable security, and then talk about getting started with automated reasoning. Before we started though, we were kind of wondering who's here for the compliance side and who's here for the automated reasoning side. So if I raise a hand, who's here for the thrilling compliance discussion? Yes,
See?
I love
Look
it.
Look at that. Look at that. Got group.
And then automated reasoning? Okay, the same people raise their hand. Okay. No, this is a really interesting topic. So unfortunately, we don't have Q&A here, but we'll try to be as thorough as we can. And there's resources after the fact in the slideshow. All right, so Tom, you can come on up. We're going to both kind of do this together. Do you want to kind of, Tom is from Coalfire, and Coalfire audits AWS for FedRAMP and for other things, PCI and such. So we have kind of this auditor-auditee relationship here. So Tom, why don't you talk a little bit about Auditor's Challenge?
Sure. So I know this is the most exciting topic right after lunch, so I'll try to keep everybody awake through this. But I think a couple of things. So as Chad and I started working with this, almost a decade ago, you remember hearing you can't move critical workloads to the cloud. You can't move to the cloud because it's not secure, or you can't be XYZ compliance. And that's really the challenge that I've been living through over the last decade or so. And when you look at how quickly things have changed, it's changed quite a bit. This year we'll do roughly 5,000 different sorts of attestations, assessments, or audits in the cloud, supporting tons of different countries throughout the world. And in those 5,000 projects, there's some unique insight that we're starting to see of where the world is going, and that's something that really I want to talk the first couple slides here to talk about what we're seeing from that, where the momentum's going, so that you can be prepared of what that future world looks like. So a couple of challenges today. So I think we've pivoted a lot from the term audit. So it used to be, you think of audit, a lot of former CPAs or CPAs coming in, you think of a lot of financial audit, and a lot of IT audit came from that world. But really, the term audit in IT space is really different. I really like the term assurance, because the way that we're working is we're all on the same page, meaning from the customer, the assessor or the auditor, as well as the service provider, we're all in the same thing. We want to protect data. We want to be transparent about it, but we also know there's no such thing as 100% security, right? We're always working and changing what we can do. So it's really about providing some level of assurance that what we're doing is working the way that it's supposed to be operating. We're doing it the frequency, and we're communicating in the language that organizations care about. So if you take a report that's designed for the federal government, you drop it to a hospital, they're probably not going to care about it. If you take a HIPAA report and you drop it to a financial institution, they're not going to care about it. So there's a lot of different changes that are happening in this world. A couple of things that have happened recently, or relatively recently. So number one, we'll talk about complexity. 15 years ago, this was relatively easy. You had to know a little bit of Windows, you needed a little bit of Linux, a couple routers, and that was probably 80% of your solution, right? You'd go in, we had firewalls, you had some databases that you had dealt with. But today you look at, you just walk the floor of any of these security conventions that we have here, right? There's an infinite number of products and services. Each of them have some new things. So the complexity of looking at these services and the technology is growing exponentially. The second part is efficiency. We've got to be able to do more with less, just like everybody else here. And as we're seeing those things, they're scaling quite a bit. The third part is evidence reliance. Saying that something is in place because somebody told me to or I did an interview, that's less reliant as re-performance testing or being able to prove it in real time or pull some things out. And you hear kind of terms like continuous monitoring, but there's some evolution that we have there. And the last part is really increasing assurance, which is what you did last year, how do we get better? right? Every year there's new breaches, every year there's new attack vectors out there, and every one of those spurs somebody saying, well, what we were providing, we weren't aware of what the risks were. We want some higher level of assurance. So those are the 4 things that are really happening today, making this world very complicated in the way that service providers and organizations and all of us provide better transparency to our consumers. On top of that complexity, we hadn't really thought about or probably anticipated how many different regulations and best practices would be coming out. So I remember hearing 10 years ago, people would come to me and say, Tom, compliance is like down here, but it's about security. And I would say, well, it's interesting. Like, what is the difference between security and compliance? I said, well, security is like more than compliance. It's doing something. Compliance is kind of the minimum. I said, all right. And I think that was kind of the mentality for a long time. Now we've come back and we've seen with all these requirements, the minimums have been moving up. And then the minimums that might be acceptable for one area are not the same minimums as some other. So you're seeing these different things that just because you pass a PCI vulnerability scan doesn't mean that you're going to be accepted to move a workload to the National Security Agency, right? Different people have different levels of what they're looking at. And so we've moved through a couple of different phases. One of the ways that I like to think about this is we're really going through security through kind of a security life cycle, and most organizations are in one of 3 phases. The first phase is security doesn't really matter. That's still a lot of organizations where security doesn't matter. Customers are not buying your product because of a security feature. Customers are buying it because of the features you provide and the cost you provide, and sometimes security might be an afterthought, maybe a CISO or somebody sends some letter and you have somebody providing some sort of write-up of what you do, and that's generally fine. Most organizations are like that in very small phases. The second phase you get into is you realize that security is part of what your customers are demanding, and if you don't have it, then you won't be able to sell or operate or grow. That's the second phase that people are at. And usually in that phase, it's a combination between what you see here on the left-hand side, self-attestations. We say we're secure because we're doing these things, or we know things are configured this way. 2, maybe they get some independence, and that can be independence within an organization, right? Their internal audit function. It can be an external audit. It can be a pen test. And we see that happening. The third phase we have is security starts becoming a differentiator, right? And that is relatively unique within the last couple of years and really growing in the cloud and security space. When you start seeing all the different products and services out there, how many of them are touting security and privacy and compliance is their key differentiator for their service and product? And again, that's relatively unique within the last couple of years, but that's happening very quickly. And when security and privacy and compliance is a differentiator for your product, you have to take the security development lifecycle very different, right? You have to treat it like a feature or a service of what you're building in the future, and that kind of says, well, what do we need to build so that we're meeting the demands 2 or 3 years out? That's very difficult to do. And so what we're starting to see now is services are growing. Our most mature organizations, we're seeing their service release cycle. They're growing the number of services about 35% a year. And then we're also seeing that the regulations they're having to meet, or the best practices, or the security they have to meet, are growing about 35% a year. So you compound those things, and what you're finding out is their security and their privacy workload is basically growing 100% every year. Right? I mean, imagine that. Some of you guys may be feeling that right now, where every year, whatever you do next year, you're looking at next year, or you're looking at 6 months from now, you're saying, I'm going to have to do twice as much work with roughly the same amount of resources. And so what we've been doing so far, we've been throwing people at it, and we've been scaling, but there's a big problem with that. With the people, if you just kind of look at some general trends, the security talent is growing at a roughly 7 or 8%. So we've got a problem where consumers are demanding input, growing 100%, and a baseline that's growing at 7 or 8% when people, that huge gap is really what's driving the automation, right? We've got to get better, and we've got to get more efficient in what we're doing. When we talk about this, we talk about automation, it's nothing new. There's fancy words around, AI and blockchain and machine. If you can get AI, blockchain, machine learning into anything, that's kind of like the big buzzword today. I like to think, we used to have dumb intelligence, right? We'd just have people looking at stuff, and we've been doing this for a long time. So I remember doing this, 20 years ago. I have to go look at a server. We'd manually go into a server and manually go into the registry and do command lines and do those sorts of things. Today, right, we have tools that automatically go through those and compare to different benchmarks, compare to different standards. Think about vulnerability scanning, right? It was only about 15 years ago that you can point 5 different vulnerability scanners at one system, and you'd get 4 or 5 different results. Some would say it's a high risk, some would say it's a low risk. The auditors would stick with the high, the organizations would stick with the low, and you'd kind of have to argue that. And we had to come up with CVEs, Common Vulnerability Enumeration, CVSS, Common Vulnerability Scoring System. Right? We created all the plumbing in place so that we can consistently communicate what's high risk, what's low risk, and have a baseline, which then we can adjust based on the environment. But automation is not new. It's something that we've been seeing for a while today. Most of you are not manually reviewing your firewalls. There's probably some sort of tool that's going through it. Most of you are not manually reviewing all your network configurations. There's probably some tool that's helping out with that. Most of you are not manually looking to see whether either patches are installed or what vulnerabilities are in place. You have automated tools that are running vulnerability scans, that are looking at patches, that are testing from the inside and outside. Automation is not a new thing, but it's actually coming into a new level that we have here. I'll turn over to Chad here on the next slide, but really, what is happening in the future? So I mentioned kind of organizations going through 3 different phases, right? Beginning, security. Phase 1, security doesn't matter. Phase 2, security is something that's important, and they kind of do the minimum, and then security is a differentiator. Well, there's kind of the 4th area, which is where people are going to. And in this place, where the features and functionalities are truly going to really differentiate themselves in what they do. So today, you're seeing an annual report or an annual piece of paper that's coming out saying, yes, this was done because I looked at a data center and I did that 7 months ago. Or I looked and I interviewed somebody and had this. We're seeing the frequency of communication is going up. So I don't want that. I don't want to see a report that's 10 months old when something's growing 33% a year. I want to see it every 6 months, every 3 months. I want to see it daily. I want to get access to certain APIs to see those in real time to see how they're changing. I want to also know, once that's happened, how you're dealing with it and how those things are changing. So the future of security and compliance in this world is going to be much more automation. It's going to be much more availability of what's out there, and it's going to be much more interactivity and communication so that we're providing a reasonable level of assurance. If we want higher levels of assurance, we can pull different products and features. One of the big challenges of that is because of the complexity we've got here, you have to really think about the architecture that you're designing. Right? The architecture is fundamental to building a strong foundation so you can build out what you need to scale. And that's one of the challenges we have today is, unless you're in that, that golden utopia that we've got of what that phase 4 looks like, what we like to call the holy grail of what security could look like in the future, you've got to build that solid foundation. And so we've been up here trying to talk about where we see the future is going, how to build and architect that foundation so you can take advantage of the products and services that are coming out there. You can build the assurance, compliance, privacy frameworks that you need, provide that back to the customers in a faster pace in real time, and truly differentiate your service in a way that others can't. This is now something that's new that hasn't been able to happen before. I'll turn this over to Chad.
Thanks. All right, so I want to talk a little bit about provable security. So does anybody remember back in math class, way back in high school, or whenever you took math, college, where you talk about mathematical proofs? Something that, like the Pythagorean theorem, or something that when you apply the actual formula, it'll apply to any triangle or apply to any slope or whatever the formula is. That's a math, and you can then go back it up and prove it. So Byron will talk more about that in a minute, but provable security is extending that same kind of idea to the security, or a security characteristic of an entire system. It provides more, it says here, mathematical proofs provide additional levels of security assurance when combined with traditional security methods. That's the kind of the subtle difference between what an automated control is and doing a proof of a system characteristic. I'll give you an example. Let's say you're trying to make sure that you have strong keys, 256-bit encryption keys everywhere in your system. The traditional approach would be, maybe the auditor would come and ask you, sit down and do an interview and say, do you have strong encryption? Yes, we do. We have this one point in the system whereby all the keys are created. And the auditor will say, okay, let's go to that system, see if they're producing 256-bit keys or stronger, and they would validate that. And then maybe if they want to validate it throughout the organization, they might go to the target systems that this this key generator vends to, and maybe check and make sure that all the keys are 256-bit. You conclude that all the keys in the system are strong keys by doing that test. And if you really think about it, you're not really looking at the whole system. You're just looking at a key control point, and then maybe the target of that control point. Another example might be password control. Today, password control, if you're going to go see what a password control is, if you have strong passwords, you go to the Active Directory policy, and you go look and see if the password history is enforced and complexity and all that stuff. And then you conclude, that's like an automated control. We conclude that all passwords are generated there, and therefore you have strong passwords everywhere. But using proofs is subtly different. It's taking the entire system, and in the case of the 256-bit encryption keys, you're taking an entire system to see if there are any place in the entire system that can possibly generate or use a key that's weaker than 256-bit. Once you define the proof and you define the checker, then you can audit the proof and test the entire code base, and then instead of just concluding with a reasonable assurance that you have strong keys, you've actually mathematically proved that you have strong keys. So this is a simple example of something that Byron will go into, but I just wanted to, this is the difference. The difference between automated control is identifying a certain point, and proofing is the entire system that is under review, or at least the scope of the system. So Byron, I really love Byron's presentations, and you're going to love it too, but at some point in this presentation, you're probably going to get lost, but that's okay. I think we're videoing this, right? So you can watch it later. But at least I do. Maybe you guys are definitely more on top of this. But prepare your mind for Byron, and he's going to get up here and do a very quick, a thesis of provable security, and it's actually very well done. But when you're listening to Byron, just think of these three things. Number one, think about the difference between automated controls and what Byron's telling you, and the assurance bump you're going to get by using proofs versus automated controls. Number two, think about what kind of things this means for your environment. We've been talking about compliance as code, security as code. Even in Steve Schmidt's session this morning, a keynote, he talked about security as code. Think about what that means. If you've got an environment like AWS that has everything defined by code, and this verification model that Byron's about to tell you can prove certain characteristics about the entirety of the code base, what does that mean for assurance? We're talking about a possible huge leap in providing assurance about a system. And then the third thing, think about, just remember, you don't have to figure this all out yourself. You could hire some automated reasoning specialists, but I think we actually hired them all, so there aren't any. There's like 20 people in the world that can do it, so we hired them all. So Byron, basically what we've done is we've taken these tools and we've baked them into some of our tools that we can provide to you, our customers. So as you go through here, and I'll as Byron puts it, clean up the mess afterwards and talk about how it applies to compliance and how you can start using those tools. But just start thinking about that, like when you start using these tools and what it means for you in your interaction with your auditors and how it's going to change your testing approach. Okay, Byron.
Great. Thank you for the great introduction. Now I'll make a mess of it. So, let's look at an example. Could the assert fail in this program? I'm going to give you a moment to think about it.
I saw like 100 people that raised their hands that said they were experts in your field. So,
and we're going to assume, as for example, in crypto applications, that we're dealing with arbitrary length integers. So actually the x, y, r, I could actually range over all mathematical integers, not just 32-bit or 64-bit integers. So the problem here is that compliance and this question of the assertion failing are essentially the same problem, right? So if we're asking, does the system respect controls that we've decided need to hold, that's the same as asking the question, does there exist an assert that we could write in the program such that the assert would fail if the compliance control failed? That's the question that the connection between that. So how many tests would we need to run to show that this assert can't fail? Any ideas? Hold up your hand if you know the number of tests we would need to run. No? What's that? So the problem is that there's actually an infinite number, right? So because x and y are a range over all integers, and there are an infinite number of integers, there is no finite number of tests that we can run on this program to show that the assert can't fail. We might get lucky, so we might choose some. I mean, imagine you fuzz it, so you try some examples and you run it, and maybe you luck out. But if we want to show that the assert can't fail, which is really what we're trying to do in compliance, then we're not going to be able to use testing in this situation. So what we're going to need to do is instead prove it. Okay, so to do that, I'm going to convert the program into the graphical representation that actually most compilers use, for example. So this is a representation of the program where the syntax and the code and the graph on the right are essentially the same thing. So it's compiler representation. So there's 3 locations, F, G, and H. And the code in red, for example, in the graph represents the code in the text. So if those 2 formulae hold, then we'll go to the location F. Then from location F, we go to location G by executing those commands. If I is positive, then we'll go through the loop. So we'll go from G back to G, executing those commands. If I is less than or equal to 0, then we'll go to H, and then we'll check the assertion. Right, so this is an equivalent representation of the program, but in graphs. And then the idea of proof is to find what we call invariance, such that we can now, in finite time and space, show that that assertion can never fail. And actually, we do that by placing formulae in the boxes. So this is kind of the magic step, if you will. I'm not going to tell you how we do this, but there are sophisticated approaches that find the invariance, and this is the hard part of automated reasoning. So it requires creativity, clever heuristics. It's typically undecidable or intractable, but there are ways to do it. Now, once a proof has been found, then auditing it is actually very easy. Sorry to use the word audit. No, so auditing it is actually extremely easy once those heuristics have been applied. So this is the sort of the neat thing, I think, from the world of compliance and how proof can bring a lot to compliance, is that the checking, the finding of the proof and the auditing of the proof are actually 2 different activities, can be done in different places and can be done with different sorts of tools. So we can divide this into finding and auditing, and I want to say a few words about that. So finding is the creative part. It's a computationally difficult part. Once done, you're done, right? You only need to find a proof once, but it's the difficult part in some sense. And then auditing the proof is by design is boring. It's very detail oriented. It's something humans struggle with, but no creativity is required. It's actually a great activity for computers. So computationally, this is a really easy activity and can be repeated often and cheaply. So said all that. So let's audit this. Okay, so we've found this proof, and so what we do is we go through each transition, right, and make sure that it holds. So that was the original program of the graph. Inside the boxes are the invariants that have been discovered by a proof engine. And now we're going to audit this proof and just make sure that the proof is valid. So for each step, we can actually construct a formula in a format called SMTlib. And this is a standard format. Many of the proof tools take this format. So we can encode the transition. So this is saying if the formula in the box is true, then is the thing that it's pointing to true? You might look at that and think about it for a second. It is, because x times y is the same as y times x. We can encode that in this SMT-lib format and then run a tool, and it will tell us if it's true or not. So all of this is decidable and really easy. For example, there's some tools like CVC4 and Z3. And then we just do this for each of those transitions. So here, for example, if this formula is true, so here it's saying if r is equal to y minus I times x, and I is greater than or equal to 0, and I is less than or equal to 0, then is r equal to y times x. And the reason this is true is that because I is both greater than or equal to 0 and less than or equal to 0, it's equal to 0. Right? So I is equal to 0, and what's y minus 0? That's y. Right? So that y minus 0 isn't really doing anything. So it's actually it's r equals y times x, which is then what we're trying to show. Right? So we've now audited, and we can use tooling for this, but we have now audited that piece of the proof. So we've taken the formula before the condition, and then through the condition, and then show that the post condition holds. And there's a lot of these, right? So for each one of those transitions, we call the tool. The tool says yes, and so now the proof audit succeeds, and we now know that the proof that was found by a person or by another tool holds. And it holds because all of these checks succeed. And so thus the proof succeeds, and thus we know that the assert can never fail. And so now I have, in finite time and space, convinced you that the assertion can never fail. And I've showed you what the tooling might look like that shows that. So now let me try and connect to some real examples. So these, we've, in partnership with Coalfire and my team, together with Chad's team, have been looking at things that we're showing in audits for PCI, FedRAMP, SOC, et cetera, and trying to look at places where we can use proof to help out. So we can't automate everything. I mean, for example, there might be like locks on doors. I can't prove with mathematics that someone has physically put a lock on a door. But then often when you look at the things that need to be showed, a lot of them are things that we can do. So for example, here we're trying to mitigate access to data by humans, and so there's a control talking about how the architecture of networks that are being used. So one thing that's cool about what I didn't think about before joining AWS is that actually much of AWS is built on top of AWS. So you have Macy, you have Lambda, you have Inspector, you have Guard Duty, et cetera, are actually built on top of S3, EC2 networking, et cetera. And so we can use a lot of the same tools that we can hand out to customers to show things. And so this was sort of the state of the art for services in AWS that were built on top of AWS when they were doing audits for various things, and the control I mentioned before was something we were trying to show. And so this is the method that we were using before. And it's not important that you read the details. The important point is that each of the bullets says auditors attempt to evaluate, and the word manually keeps showing up, right? So what's happening is that conference rooms are being booked, people are sitting in rooms, people are running tools, they're coordinating, there's spreadsheets about who's done what, information's being coordinated, there's IMs and emails, and lots of coordination, lots of people. It's actually a very expensive process, both for us and for Coalfire. So the new method is to use a tool that we've developed internally and is a part of a new feature release in Amazon Inspector, which reasons automatically about networks built on EC2. And it's using the techniques that I described before where there are graphs. So there's some magic that happens, there's some heuristics, and then we construct a proof, and then that proof shows properties about the reachability of EC2 networks. So we're using Tiros to determine the scope of the boundaries for the audit. we're using Tyros to automatically search for all of the entry points into the network, and then we're using Tyros to automatically show that this property holds about networks going, all traffic going through Bastion hosts before it gets to the payload, if you will. And so this is, I'm going to show you a demo, and this is a demonstration of finding a proof, not auditing proof, right? So I'm showing you sort of what that looks like for the person doing the work for the audit to try and use tooling to try and find a proof.
I'm going to give a demonstration on how you can use Tyros to scope network connections to production hosts. For this demonstration, I've deployed the CloudFormation template provided as part of the AWS Quick Start reference deployment for the payment card industry data security standard. This means in the account that I'm using, there's a management VPC with a Bastion host and a production VPC with application servers. And I'm going to scope the connection to those application servers. Here's what the EC2 console looks like. There's these application servers, the Bastion host, and some other servers. You'll see that there is the production VPC and the management VPC. And I just wanted to point out that the network access control list for the production VPC only allows SSH traffic from this management VPC. So I'm going to go ahead and open a console, and I'm going to run this command, which will list all of the ingress connections to ENIs in my account that are attached to instances that are tagged as app server. So this is going to list a bunch of connections that can be established from CIDR ranges within my VPCs, but I'm kind of more interested in CIDR ranges that are non-RFC 1918 compliant. So I'm going to scope down this query even more. So I'm going to also require that the public IP addresses do not match any of the RFC 1918 compliant CIDR ranges. And we'll see that it comes up with nothing. But just to show that everything's working, let's go ahead and alter the security group of one of these application servers. I'm going to go ahead and add an inbound rule for all TCP traffic and allow traffic from everywhere. Now I'm going to run the query again. Notice now that I have a bunch of findings for the IP address 8.8.8.8 on all sorts of ports. But what about if I just check port 22? We'll see that Tyros doesn't find anything. This is because the network access control list denies traffic from port 22 except from the management VPC. But let's write another query. This one is asking which instances can SSH to the application servers and what are they called? And we see it finds that the Bastion server from the management VPC can actually connect to 2 of the application servers in the production VPC. So this demo demonstrates that Tyros reasons not just statically about the security groups and ACLs and route tables and internet gateway, but it uses all of these controls together to determine what reachability actually looks like to the instances.
Great. So another control is that data at rest needs to be encrypted. So this is coming from PCI, FedRAMP, SOC, HIPAA, et cetera. And the idea is, again, to keep humans away from the data. So in the old audit method, what was happening is service teams and the auditors would agree on areas of the code where attention should be focused. Screenshots were generated, and then that was tracked, and then individuals would look at the screenshots of code and try and identify to their belief that data couldn't be saved to storage without being encrypted. So the new audit method that we're using is to use program proof tools, which take the entire source code and then automatically prove that data can't flow directly to disk. It needs to go through an encryption procedure. So again, this is a demonstration of proof finding, not auditing. I have, in a moment, I'm going to show you a little bit about auditing, but this is an example of us using tools to find proofs about programs and their connection for this control.
Here I have Java code designed to encrypt incoming data and upload it to S3. I want to be absolutely sure that this code is safe and never uploads unencrypted data. I'll run Dragonstone to verify. Dragonstone's found a problem. It's explored all possible executions of my code and is reporting a problem on this line. Here it says the ciphertext variable is possibly unencrypted. What went wrong here? I think I see the problem. This encryption function returns a new array of encrypted bytes rather than modifying its input array. So if there's an exception from put object, my retry logic will upload unencrypted data. To fix this, I'll move the encryption step to be separate from the upload step. I hope this solves the problem, but I'll run Dragonstone again to verify. Dragonstone is still reporting a problem on the same line. What went wrong here? It looks like the encryption step itself can throw an exception. That would leave my data unencrypted when it's uploaded to S3 in the retry logic. To fix this, I'll move the encryption logic to be separate from the retry logic. I'll confirm that this is safe with Dragonstone. Success. Dragonstone has analyzed all possible executions of my code and confirmed that none of them can lead to unencrypted data being uploaded to S3.
So now let's look at what auditing looks like. So this is a different activity where we're not using heuristics to try and find a proof, but now we want to take a proof that's existing and we want to audit all of the details.
This is a demonstration of proof finding and proof auditing. On the right-hand side of my screen, I have a logical formula that I want to prove. To find a proof of the formula, I'll use CVC4, an open source proof finding tool. CVC4 says that the negated formula is true, but suppose I want more evidence. I can ask CVC4 to generate a proof. Proof shows all the steps necessary to prove the formula. As you can see, it's fairly large. That's because it shows all the steps of the proof with no creativity or leap of faith. Now, I can use an independent proof checking tool to audit the proof. I'll use Coke, an open source proof checking tool. Coke says that the proof is true, verifying that the proof is correct and that it actually proves the original formula. Finally, let's see what happens if an unscrupulous user tries to break things. I'll modify my formula by changing a single constant. So now the proof's correct, but for the old formula, not the new one. I'll ask Coke to recheck everything. The check fails this time. Coke detects that the proof doesn't match the formula. Now we've shown how to separate the process of proof search from proof audit, allowing auditors to independently verify the result.
So what we saw there was Tyros is the tool we were doing network reasoning. Also tools we use for example, reasoning about policies. Tools we're using to reason about protocols, crypto protocols. Tools we're using to reason about programs. For example, to prove the correctness of parts of S2N RTLS implementation. All of them are calling this class of tools called SAT solvers. CVC4 is one of them. And so what happened in that demo is he ran CVC4, which found a proof, and he generated a proof for a separate tool called Cock, which has an extremely simple core. Many eyeballs have looked at that, and we know that that prover is correct. It's actually, that prover is the prover that's been used, for example, to prove the four-color theorem, and the Feit-Thompson result recently by George Gontier. To repeat, finding and auditing proofs are different. The creativity, the heuristics, the magic can happen in tools that run on-site or off-site or in the cloud or whatever. And then independently, auditors can take witnesses found of the proofs and replay them extremely efficiently using tools that are easy to understand. And that's the strategy that we're now pursuing with our audit partner. So with that, I'm going to hand it back to Chad.
Thanks, Byron. All right, so now obviously you are not going to go back and do proofing maybe manually. Maybe you can start, but instead of having you do those checks you saw in the demos are things we've done both internally for our own environment and also built them into the tools that we provide you as customers. So here's the regular shared responsibility model. We've integrated, and I'll talk about which tools, into client-side data encryption and data integrity authentication and other kind of services that we provide to you. And on our side, as mentioned, we've been working with Coalfire to change the way that they're doing audits in our environment. So instead of doing population sampling and testing, in some cases, areas that have been subject to a proof and we can prove it, then they're relying on that evidence instead of doing that sampling, the population sampling, which is getting less and less effective over time. So the core tools, and Zelkova and Tyros are the internal tools that we talked about, but they're found in these config management rules, Macy, GuardDuty S3, S3 public block public access, IoT device defender, and trusted advisor, as well as Amazon Inspector. These tools are available to you today, and as you use them, think about how you can change your own audit procedures. Because using these tools and understanding the characteristics of your environment, your AWS environment, will allow you to change the way that your auditors are approaching the audit. Maybe they're going to get a lot more assurance over some aspect of the system than they can by doing the traditional methods. So these tools, everything Byron said as far as our development of these techniques are delivered to you under these services, and we're building more and more of this kind of thing into the services as we go.
And Chad, I'll add. I mean, I think it's a key point, right? You saw a lot of complexity we had earlier today. There are 5,000 plus assessments we have going on. Very rarely do people ask if we have knowledge of these tools. All right? Don't assume that, whether it's your internal auditor or external auditor or anybody, don't assume that they know these tools. You should be demanding and asking that you're working with organizations that are familiar with the services and the technology you've got. Otherwise, there's two things. They may be doing things wrong and applying methods that work for certain technology that doesn't work in your organization. Or two, you're paying to get them up to speed on your sorts of solutions. So I can't emphasize enough, in order for this stuff to work, in order to get the best level of assurance, right? Like, would I rather get some assurance that every password is secure? Would I rather sample, 100 out of 10 million servers? I know which one provides a better level of assurance for me, but you can't do that. You can't even ask that question unless you're familiar with the tool sets and the architecture that's out there. So it's critical that organizations are up to speed on what these are and know what they do and know what they don't do and what their limitations are. So, Tom, what would you say if someone were to ask you like how to approach your auditor with this kind of thing? What would you say? What would be your advice to them? I think there's a couple things I'd think about, which is one, is what you're doing today sustainable? right? So I think if you're looking at that in your organization and said, yeah, what we do right now, it's totally fine. We see it once a year. Some people come in, they do it, they get a report. Our customers are fine with it. We're fine with it. We're not in an environment that has a lot of innovation. We're not changing a whole lot. We're very dynamic. We're not entering new markets. Then it's probably fine in the status quo. But if you are in an organization that has a lot of innovation going on, that has a lot of technical change, that's expanding into new markets and services, into new geographies, then you have to think about what those problems may be. And so one of the questions that we ask from an assessment is, what is your 2 or 3 year roadmap, right? What are the types of services and what are the types of best practices or frameworks or compliance that you think you're going to have to get? On the flip side, those folks are then asking us that come back with that plan. Here's what we think we're going to do. We're probably going to need these sorts of things. How would you guys go and build a plan so that we can work with these? So that's where working together to build out kind of that long-term plan is really critical in those 2 areas. And the last part is ask for a couple proof points. We've got a couple ones where we've worked with some AWS customers. One of them took a process that used to take 18 months manual to kind of get through and get some government certification, and now they cut that down to 6 months. Right? And that's huge for them because that year is a year of business. It's millions of dollars. It's contracts. It's a differentiator for them. So getting some of those proof points where we talked about a lot of theoretical here, but now we have a lot of actually really cool proof points that you guys have seen in some of the keynotes and stuff that it's starting to happen now. So be familiar with that and ask yourself, could those sorts of proof points happen in your organization? And are you working with people that are thinking and are forward thinking enough about how to actually accomplish that?
I'd recommend going to this website. It's the Provable Security website. Articles and blogs, things that you can look at to start to try to synthesize and figure out how it works in your own environment. There's also a couple related breakouts. These are around automated reasoning, deep dive into analysis with policy analysis with Zelkova. There's a repeat session there. Automated reasoning tech at AWS, the evolution of that. There's other of these, these are all Zelkova sessions, but these are helping introduce a new aspect of the compliance as code, security as code aspect of once it is code, once you are in an environment like AWS where all the code can be tested or proven, you're in a much better ability to prove certain aspects of the entire environment.
There's a talk by Neha Rungta and Eric Brandwein today about the evolution of automated reasoning in our at AWS.
That's that.
That's the third, the two. So that's at 4:45 today, and I think that might be extremely entertaining.
Yeah. Okay. We appreciate you attending, and thank you so much.
Thanks.